Rational inequalities. They're very similar to rational equations, except whenever you have a number that goes above or below whatever makes the number in the denominator equal to 0, it can change the number, the sign of the number total. For example, let's say I have 1 over x. We know x can't equal 0, but if x is negative 1, that would give me 1 divided by negative 1, which means my answer is negative. But if x was positive 1, I would get 1 over positive 1, which means my answer would be positive. So whenever a number, the denominator goes from positive to negative, what it does is it changes your answer from positive to negative or vice versa, and that can have a drastic effect on a rational inequality. So we are first going to start out by solving for x to figure out what makes x a true sentence as an equation. So I'm going to rewrite this as an equation. So it'll be x over 3 minus 1 over x minus 2, and I'm going to set it equal to x plus 1 over 4. And then I will do what we've done all the way through this section so far, is find a common denominator. Common denominator is going to be the common denominator of 3 and 4, which is 12. So that'll be 12 with the x minus 2 on both sides. So again, that's going to be 12 times x minus 2. So 3 goes into 12 4 times, and of course the 3 will cancel out. So I'll have 4 times the x that's over right here, so 4x times x minus 2. And then the x minus 2's will cancel. So I'll just have 12 times negative 1, so that's negative 12. And that will equal, over here, the 4 will cancel, leaving a 3 here. 4 goes into 12 3 times. So this is going to be 3 times x plus 1 times x minus 2. So I got to do my distributing now. So this will give me 4x squared minus 8x minus 12 on the left side equals, I do need to distribute 3 to the x and the 3 plus 1 here. So that would give me 3x plus 3. And then in another step, I need to distribute that with x plus x minus 2. So that will give me 3x squared. 3x times negative 2 is negative 6x plus 3x minus 6, or 3x squared minus 3x minus 6. And on the right side, I've got 4x squared minus 8x minus 12. Well, I got a lot of x squares in there, which means I'm dealing with a quadratic equation, so I need to move everything to one side of the equation. So I will subtract negative 3x from both sides, and I think for speed's sake, I'm going to go ahead in the same step, add 3x to both sides, and add 6 to both sides. So all of that is going to cancel and leaving me 0 on the right side. On the left side, I'll have x squared minus 5x minus 6. That is factorable. So that will factor into x minus 6 and x plus 1. Then, of course, I will set those equal to 0. So x minus 6 equals 0. X plus 1 equals 0. So x will equal 6. X will equal negative 1. Phew. So remember that this was an inequality. So I'm going to take those answers and I'm going to place them on a number line. So I have x equals 6, that's roughly here, and x equals negative 1, we'll put it on the other end of the number line. But recall I said that where there is a denominator that equals 0, the values of x that make the denominator equal to 0 can also cause changes on the number line in a rational inequality. So I'm going to place a 2, because if x is 2, I would get 0 in the denominator on the number line as well. And I'm using open circles because it's less than and not equal to. And what that does is it places 4 different sections on the number line. We have a section that is to the left of -1 for numbers that are smaller than -1. We have a section for numbers between -1 and 2, a section for numbers between 2 and 6, and a section for numbers larger than 6. So what I'm going to do is I'm going to do a test point in each one of those 4 sections and see which of those test points makes a true sentence. So I'm rewriting the original problem with the inequality sign this time, and I am going to replace the x in each one of those with a test point and see if it gives me true sentences or not. So I'll replace this x and this x and this x all with a number to the left of -1. So let's say -2. So that'll give me -2/3 minus 1 over -2 minus 2. Is that less than, that's what I'm trying to figure out, -2 plus 1 over 4? Well, -2/3 would be -2/3 minus, this would be 1 over -4, which means it's actually going to be 1 over +4 plus 1/4. Is that less than -2 plus 1 is -1/4? Is that true or not? And -2/3 plus 1/4, that would be -5/12. And yes, that is less than -1/4. So I would shade this area over here. And then I got to do it again for a number between -1 and 2. So let's do a quick erase here. And now I'm going to replace what the x's were, instead of with a -2 this time, with a number between -1 and 2, and 0 is a really great number to use there. So 0, 0, and 0, and we see if that's a true sentence again. So 0/3 is 0, minus, so this would be 1 over -2. 1 over -2 is -1/2, which means it would actually be plus 1/2. Is that less than 1/4? Well, 0 plus 1/2 is 1/2, and 1/2 is not less than 1/4, so that's a big no. So that means I would not shade between -1 and 2. And then we do it again. This time we pick a number between 2 and 6. I think what I'm going to use is 3 this time. So I'd have 3/3 minus 1/3 minus 2. Is that less than 3 plus 1/4? Well, 3/3 is 1. Minus 1/3 minus 2, that would be 1/1, which is also 1. Is that less than 3 plus 1 is 4. 4/4 is 1. So is 1 minus 1 less than 1? Well, that is a yes. So I will shade in between 2 and 6. And then pick a number that is larger than 6. And so a number larger than 6 would be 7. So replace all the x's with the 7. So that would be 7 there, 7 there, and 7 there, and we do it again. 7/3 is just 7/3 minus 1/5. Is that less than, well, 7 plus 1 is 8. 8/4 is 2. So is 7/3 minus 1/5, is that going to be less than 2? I think it's pretty close. 7/3 is 2 1/3 minus 1/5. So if you're taking 2 1/3 and you're only subtracting 1/5 from 2 1/3, is that less than 2? And it is not. It's going to take more than subtracting 1/5 from 1/3 to get you lower than 2. So don't even have to figure out exactly what the answer is. I just got to figure out, is it less than 2 or not? So that's a no. So we'll use the number line as a guide. It is not going to be your final answer. Your final answer is going to be that x is less than -1, or x is between 2 and 6, and we can write that as 2 is less than x is less than 6. That's how you write x is between 2 and 6.